Hey, Vsauce, Tom here, and I just so happen to have the ability to solve a Rubik's Cube. And I also just so happen to be here in a very dark room with some color adjustable LED lamps. So obviously, that means that today I'm going to be answering the question, how will colored light affect my ability to solve a Rubik's Cube? Now, for those of you who don't know, and if you're in my physics class and watching this, you probably should know, when you shine a white LED light on an object, the LED is actually emitting 3 different colors, red, green, and blue, which add up to look like the color white. So each of these colors hit the object, some of the light gets absorbed, and then what doesn't get absorbed bounces back off and gets picked up by your eye. But what if the object was yellow, like a banana or a sponge? Well, then the object has a yellow pigment, so the light also has to travel through a yellow filter, which removes the color blue. So now, only the red and green light will bounce off, which combine to give us the color yellow. So if we were to shine a magenta light on something yellow, which is made up of the colors red and blue, then the blue light would get filtered out and the object would look red. So the same thing's gonna happen to the Rubik's Cube, right? Well, the pigments used in the Rubik's Cube aren't the exact same colors as the lights that the LED uses, but it's still gonna make it a lot harder. What I plan on doing is solving the Rubik's Cube 3 times for 5 different colors: white, yellow, red, green, and blue. I'll average my solve times and make note of any mistakes I might have made while I was solving it. So let's get started. My first 5 solves are under a white light to act as our control group. Now, while I'm solving these, I should explain something about my solve process. It involves a bunch of different steps, but each step has a setup and then an algorithm. The important part here is the setup, because it always requires me to visually match certain colors together on the cube. If I can't distinguish between those 2 colors immediately, I need to take a bit of extra time to confirm if I'm using the right pieces, or in some cases, I literally just have to guess. So, with this information in mind, we can sort of predict how many steps will be more difficult for each light and hypothesize just how much harder the cube will be. So after solving the cube under the white light 3 times, I had an average solve time of 1 minute and 20.2 seconds, and I made 0 mistakes while I was solving. Next up, I solved under a yellow light. Now, since yellow light contains both red and green, the changes to the cube remained minimal, as you can see in this color diagram I've made here. The worst it did was cause me to take slightly longer to distinguish between these pairs of colors. So essentially, I wasn't expecting yellow light to be that much harder, and while this did turn out to be the case, I was sort of surprised at just how little of a difference it made. My average solve time was 1 minute and 25.21 seconds, which was only about 6% longer than the control. In addition, I did make 1 mistake during a solve, and if I'm being honest, it wasn't actually because of the light. It was kind of just me being an idiot. But that sort of begs the question, if I hadn't made that mistake, wouldn't the average times be almost the same? It's almost like the yellow light didn't actually affect my ability to solve at all. Next, the green light. Now, as you can see on the color diagram, the colors are noticeably different, especially white and yellow. Since more of the colors could be mistaken for each other, I expected this to turn out significantly more difficult than the yellow light, and that this is where I would start making a lot more mistakes. As it turns out, yeah, the light caused me to make 2 errors during my first solve, and then another error during the third solve. So my average time for green ended up being 1 minute and 40 seconds, which means on average, these solves took me almost 25% longer than the control. Next, blue. So just have a look at the color diagram and give your best guess as to how badly you think this would impact my ability to solve. Since the changes were relatively similar in scale to how the green light changed the cube, for example how the red and orange were the colors giving off the least light and therefore were the darkest, I expected the blue light to give me about the same level of trouble. Well, I averaged at 1 minute and 47.1 seconds, which was only about a 7% increase from green and approximately 34% more than the control. Though the interesting thing here is that I didn't make nearly as many mistakes. I only made 1, and it was on the first solve. Lastly, red. Now, it should be immediately apparent why I saved this for last. I mean, just look at the color diagram. The red light is a major component of all 4 of these top colors, and by that I mean that 50% or more of the color is solely red light, except white. That white has like an equal amount of everything, so it just reflects the color you shine on it. But really, the cube was basically just glowing red. In fact, the only colors I could actually be sure about were green and blue, and that's not much help. So the red light affected every step of the solving process. It actually took me so long and was so difficult that I only solved it once. After that, I was done. And that solve took me 6 minutes and 18.66 seconds. Let me put that in perspective real quick. That is nearly 375% longer than the control average, and that doesn't mean it took 3.75 times as long. That means it took almost 4.75 times as long. This solve under the red light was about 5.5 times as long as my fastest solve in this whole video, 1 minute and 9.66 seconds, and was nearly 3 times as long as my next slowest time, 2 minutes and 7.1 seconds. But that isn't even the worst part. I made 4 mistakes while solving this. Or at least that's what I thought, until this happened. So yeah, I think it's very safe to say that red is by far the most challenging color of light to solve a Rubik's Cube under. Thanks for watching.